for you here. Great. So in order to make something like that for a truss, you need to go to the modeling again, modeling environment, create a new file into the model and click OK. So what you want to do, you want to start a sketch in an X and Y plane. So what I will do, I'll click on a sketch. I'll pick the XY plane, you can see here, and I click OK. So while I'm in the X and Y, I go to the rectangle, make the a square, and you can see that I've made a square with dimensions. So because I want to continue with just these two dimensions, first of all, I need to make sure to go to the more and switch off the continuous auto dimensioning. And I will come back here and then double click on it to put it and change it to the 50 millimeter by 50 millimeter. Even to be honest, if you don't want to have to do those two dimensions, of course I can use the equal geometry constraint. But for now, it's okay. And what I'm gonna do now, I'm gonna make 2 more lines. I create a straight line like that, and then I connect it from here to there. And make sure that actually I connect it properly, yes.
Sorry, I haven't really been following this. What's this we're making?
So we are making a truss, and I've already done that. So you can, if you listen from now on, it's the same thing. So I'm just doing it one more time.
You're doing it again? Okay.
I'm doing it again, yes.
Thank you.
You're welcome. So what I've done, I just went to the X and Y plane, and I started sketching a normal rectangle, put the dimension for it, and create these 2 lines. So what I've done, I went to the sketch, X and Y plane, and then I make the rectangle, in this case a square because it's 50 by 50, make these 2 lines. And then once you create those, click on escape, because I don't want to give dimension. I'm gonna go to the geometry constraint and click on the equal length, and I will say the first one, this line, with this one will have the equal length, and you can see the dimension is changing. So already done the full truss. I'm just repeating it one more time for the recording to make sure you have a short recording rather than a long one. And what I'm gonna do now, I'm gonna put this dimension out because it's bothering me. I don't want to have it inside the sketch. So it's really important. If you want to put a dimension, make sure it's always outside of the sketch. And I'm gonna draw a parallel line from here to there. And if you do that, automatically software should pick it up as a parallel. You can see it shows the parallel. If in case you didn't get it, of course, you need to go to the geometry constraint and make sure you apply the parallel on that. So this is my sketch in X and Y plane. Once you finish it on that, you click on the finish a sketch. And what you want to do, you want to make something similar to that, but in order to make it easier, so I'm gonna draw on the same sort of things I have here, but because I want it in another plane with a 50 millimeter distance, what I'm gonna do, I'm gonna create a new plane. So I'll go to the datum plane, change this one from the infer to the distance. I'll pick the origin, which is the X and Y plane. I type 50 millimeter on the distance and I click OK. And if you see, I have another plane on the top with a 50 millimeter distance. So what I'm gonna do, I'm gonna start drawing on it. So I click on a sketch and I will pick that plane that I created. So I click on this one and I click OK. So I'm in that drawing environment. I put it into the fit mode to be able to see it, and I start drawing on top of the original drawing I have, and I will continue with those lines. So because you're technically drawing exactly on top of the previous sketch, you don't need to put any dimension, you don't need to put any constraint. It automatically get everything from the reference. The only difference in this case, rather than having that line, I will draw the line in the opposite direction and put it like that. And once you finish, you click on the finish sketch. Yes, Carl.
Are all the lines 50 centimeters long or whatever?
50 millimeters long, yeah.
Okay.
And because I defined 2 and then the rest is technically those 2 dimensions are run again. Thank you so much. And once I've done that, then I want to connect these together using the 3D sketch. 3D sketch in the NX, in order to do that, because if I click on the direct sketching, I have to pick a plane. Every time I click on this, I have to pick the plane. 3D sketching, in order to activate it, you need to go to the curve and pick any of these which you want. In this case, I want to pick the line, and I will just start drawing from there to there. But make sure you zoom because you want to have a closed curve. Otherwise, once you do the FEA, you will see that there are some issues there. And you just make a line on the top, make the line on the bottom. So you can see I close the back. What I'm gonna do, I'm gonna close the top as well with the same sort of technique. I will click there, I will click there as well. Close the top. I want to close the front of it as well, and I will draw a line from here to there. But make sure whenever you do that, you rotate it to make sure actually you pick the right plane for you. And what I'm gonna do, I'm gonna close the back as well. Cole, do you have a question, or is it legacy?
How do you draw above the other drawing? Like, how do you make it 3D from?
Okay, sure.
Sorry.
No, it's okay. Yeah, it's a good question. Yeah. So in order to activate the 3D on the NX, you need to go from the home to the curve. Do you see the curve on the top? Click on that, and you see a curve area in here. Any of these which you pick, these are the 3D sketch. So for instance, if I want to sketch from here to here, I'll click on the line, and I will click on the origin to where I want to go. So you have the select point and the end point. This technique is really useful, especially if you want to make a wing or these kind of things.
What you put it? So you put it in isometric, and then you decide where to.
Yes. Yeah, to go.
Okay.
Exactly.
Sorry, I'm just trying.
No, it's okay. That's a really good question. Yeah, because if you don't put in the isometric, whenever you create a 3D sketch, it will try to guess what kind of planes you want to draw in it. So technically, every sort of these is attached to a plane which is not visualized here. So it's important to put it into the isometric or the different views so you would be able to see it properly. And there are 2 more lines that I want to add. Let's do, for instance, this line to that line, and I will go again with 1 line in the other directions. Let me see whether you pick it up or not. Okay, and I will click this one to there, and I will make sure it's that one. And there should be 2 more lines. So 1 at the back, and which are gonna go from here to here, and I click OK. And there is 1 more line on the tops, and make sure all these lines which I apply in the opposite direction of the other one in front of it. So in this case, for instance, here would be from here to here, and click OK. And you can see I created something like that. So once you have this one, something is important. I think the only thing is important is that to make sure you have 9 lines. You can see 1, 2, 3, 4, 5, 6, 7, 8, and 9 lines. So you have 9 lines, and on the 9 additional lines that I created. And make sure you save it. So I will go to the save, and I want to use the save as because I want to create a new folder. And make sure you don't save it on your C drive, because I received an email from one of your students. It was trying to save it on C drive and doesn't let you. Yeah, because it's a virtual machine, you don't have access to that C drive, and save it whenever you want. In my case, let me make sure I put it in the. Okay, so we'll just create a new folder. Create a new folder because I want to tell you what's going on with that folder later. And I'm gonna call it tutorial 1. And in here, I will put it as a truss and make sure it's a .prt file. And I'll click OK. So we just save it in a folder. And if I go to that folder. So let's wait for it to save. Sometimes these virtual machines, they're slow and I completely understand. It depends on the demand at the time. Let's wait for it. So do you have any questions so far? Everything is fine. Just saved your file. You can type in your question, or you can raise your hand and switch on your mark so you would be able to continue with it. I'm not sure what's going on with that. Thank you so much, Sam. Yeah, do my best to make it easy to understand, because we are not in the university, so I completely understand your situation as well. Good. So once you save it, if you go to the file, thank you so much, first. You can see I have one file called Truss, and it's a .prt file. So what I'm gonna do now, I'm gonna take it to the next step, and let's say a designer gave us that Truss model, or you as a designer designing, and you want to put it on an actual test virtually to see how it works. So in order to do that, we want to take it to the Finite Element modeling environment. In order to do it, go to the file, and in here, go to the from file, you go to the different environment. NX call it these days pre and post. It's basically pre-processing, post-processing, but that's the NX simulation. And you can see here, it says that it's the tools for finite elements modeling. So I will repeat it one more time. Click on the file. From here, go to the pre and post. Once you click it on there, now it opened the other part of the software, which is the finite elements modeling part of it. So once you buy these softwares, the license, it doesn't come with that. So you might only get the CAD, you might get the CAM, or you might get the FES. So these are the different components of this software. It doesn't come with everything together. So you have to just buy them differently, because these are really powerful tools. Finite elements modeling of the NX is quite well done in industry. And there are a few more that I will discuss it in a second. But basically, for instance, Rolls-Royce Aerospace use that one. So we have the various of these software they use in industry, but NX is one of the good one, actually, especially for a structure. So in here, you can see here we have the finite elements modeling and simulation. Simulation is finite elements analysis. A wave technically is a link to the geometry. And a split, once you can, rather than you study the full body, if for instance it's completely symmetrical, because you want to save some time, especially in processing, because if you have a complex geometry, FEA might take a long time, depends on how powerful your computers. In industry, if you have a complex geometry, they use the cluster computer. They have to connect hundreds and thousands of computers to be able to process it, and it is quite common in industry, to be honest, because these machines won't be able to do let's say a really complex structure like a bridge. So then you try to simplify it by using the split body. This is something we will cover next week. But for now, we want to do it really simple. We have a simple structure here, and we want to do a simple finite elements analysis on that. So in here, click on that and create a new finite elements modeling and simulation. We're gonna do that together. So it's really important, click on this one, not the one below. Click on that. So we're gonna create a finite element modeling, the mathematical thing behind it, as well as doing the simulation. Click on there. And once you click on there, you will get the finite elements and simulation menu in here. You can see you're gonna create two new files. One is the finite elements modeling.fem, and one is the .sim simulation file. And where it save it, it automatically save it on that folder. That's why I ask you to put it on the folder. Don't put it on the C drive. Don't put it on the desktop, because then it will mess up. You can see now from now on, you will get few more files. And what I'm gonna do here, first I have to tell the software what's the body. Because here I want to only use the lines, what I will do, I will go to the geometry, click on geometry options, and tick lines. Because what I want from that geometry, I want to lines would be imported in Finite Elements modeling and simulation environment. I will click OK. So this one is really important. I'll repeat it one more time. Click on geometry options and make sure lines is ticked. And then you would be able to define what kind of solver you're going to use. The solvers is the different kind of mathematical equation to go and solve it. These solutions, they are really important. Nastran is quite well known, and Siemens use it by default. But of course, for instance, if you want to analyze the CFD, computational fluid domain, if there's a thermal or there's a flow, you will study on that one. Let's say ANSYS is another sort of really useful software, and hopefully with next year you have some sessions on the ANSYS, so you can compare which one is better and where it's better to use the ANSYS. Abacus is another good software industry, they use it. LS Dyna, it's quite well known in the automotive industry, especially for crash. It is the same sort of software we used to use in BMW, and LS Dyna is good. The beauty of NX, it can still use those kind of solution. It can use those kind of mathematical equation from those. In this case, we're gonna go with the Nastran. It's quite well known, and especially if you have a really simple structure, Nastran is the best one, to be honest, if you want to use. Analysis type is a structure. I don't change anything, and I will keep everything as default, and I'll click OK. So I haven't changed anything here. The only thing I changed, it was the ticking the lines into the geometry. And wait for it, because the software gonna now create a few files for you and take you to the solution. Now I'm gonna ask you, okay, what kind of solution do you want me to use? You can name it, you can change the name. I'm happy with that. You can even again come here and change the solver. I'm happy with the Nastran, as I said, and also the solution type. These ones will give you the different kind of post-processing, the different kind of results. I'm gonna go with the default one for this tutorial. Next tutorial we'll get a few more results from it. So I don't change anything here. I want to keep everything as default. And I'll click OK. Now you can see I'm into the simulation environment. In here, so in your case, you have the simulation navigator on the top. On the bottom is a post-processing navigator, whence you would be able to see the results and the graphs that will come here, which we will discuss it later. If you come here to the simulation file view, do you see that? The simulation file view. If you open it, then all the files that you have open in here will appear here. I had the model 2, I don't want to use that one, so it's okay. But in here, if I drag the mouse, you can see there are 4 different levels. 1, 2, 3, and 4. These are really important and we're gonna use them. First is this one. This one is an actual part. You can see once you double click it, it opened the dot part, which basically that's the geometry I have. If I go to the higher level, you can see it shows this one, which basically tells you now you're gonna link the part you have to the simulation. The software done it automatically for me, so I don't need to do anything on that. So that's the wave link one. Higher level in here, do you see that one? It's a small cubes. That's the mesh. So whatever I'm gonna do with the mesh in terms of applying the mesh in terms of the defined materials is coming this level. And you can see once I click on that one, these toolbar on the top would become different. And if I click on here, that's the actual simulation. Once I click there, you can see that on the top will change sorry, to the simulation level. So these sort of things, the software is smart enough to keep changing the menu for you as well. This is really important because I usually get a lot from the student that I don't get the same sort of toolbar because they are in the wrong environment. So what I want to do now, it's let's save the file and I want to show you something. Let's save it first. So what we've done, we came to the finite elements modeling environment. And now from now on, we need to take some sequence of steps, which is the same things for any other CAE software, any other software which we want to do FEA. First, you need to apply the mesh. You want to make it to the smaller pieces. So what I need to do, I need to go to the mesh level, I double click to come to the mesh level. And if I go there, you can see the mesh toolbar would appear. So what I will do in this case, because I have just the lines, I want to use the 1D elements. If it was a 3D model, then there are two options. You can do the 2D or 3D, the 3D mesh, which we'll discuss it next week. Not next week, the week after, next tutorial session. So basically what I need to do, I need to go to the mesh. You can see I have the 3D tetrahedral, 2D mesh, these sort of things. If you click on more, you can see I have an option for 1D mesh. So please click on there. I will do it now, and then I will stop the recording, and then I will do it slower for you later so you can do it with me. So now please just follow this one, and then I will give you time to do it at your own time with the step by step. Now I want to define what kind of elements or parts of this design I want to apply the mesh. I want to apply on everything, so I can either draw the mouse like that, or I can use the Control A. It's the same things. Computer is really laggy, so it's better to use the Control A. But of course, you can drag it. Something is really important. If you want to make sure you have accurate like bind, make sure you have 23 objects selected. If you designed it correctly, you should have 23. If in case you don't have it, it's okay. Let's continue with the today's session. But of course, the result you get might be different with me. Of course, definitely would be different with me. So make sure you have 23, and I've designed I've picked everything. The other thing in here, the type of it, I think in your case it would be C-bar or C-beam. Make sure you change it to C-rod. This time, because the element property is different, the way you apply the mesh is different, because it wants to assume that's a rod, so we will change it to the C-rod. How many mesh elements do you want to apply for that? I want to make it one. Every line is one mesh. So every line is one mesh. I will click one. Of course, this is a really simple FEA. For the next session, we'll go with the different methods of doing it, not the methods, the different number of elements, and compare them between each other to can see that the mesh is really important, because the result you get from the two different meshes might be different. And make sure you tick the merge nodes. So what it does, once you have the nodes in the corner, it will merge them together. You will have one single nodes. And also the merge node tolerance, keep it by default. Don't change anything. And also tick the automatic creation. So the only thing you need to define, make sure you use the Control A or drag the mouse, get all the objects, change the type to the C-rod, number of elements is 1, merge the nodes, and click on the automatic creation. And click OK. So once you've done that, I want to apply the material to it. So what I'm gonna do, while I'm still into the mesh, environment, what I will do, if I go to the simulation navigator, if I click on that plus, let me drag the mouse here, you can see I have the 1D collector, which means a group of the 1D mesh, and also you have the C-rod collector in here, and also the 1D mesh in here. And the number of elements is 23. The reason I have, because I had 23 lines, of course I will have the 23 number of elements, because every line is one element in this case. So what I'm gonna do now, I want to double click on this one, and you can see if I would double click, I would be able to edit it. If in case you made a mistake, you want to modify it, you can always come here and edit it, or of course I can come here and click on edit. If I go to the C-rod collector in here, if I click on edit, I will get the mesh collector area. If I click on that edit option next to it, then I would be able to see the material in here and define it. Do you see that one? Choose material. So what I will do, I click on the choose material, and I'll pick the material I want to have. I think in this case is a steel, if I remember correctly. Yes, I will pick this one in a steel. And also each of those will give you the different properties, of course. Click OK. I want to give the area as well. I'm going to give the depth of to that line as well because we created just the normal lines, the 2D lines. And the area in here is a 12.567 and click OK. And click OK. So once you've done it, then let's visualize it as well. So if I come here, I have an option called Edit Display. Click on that and make sure here the display section it's solid and click OK. Now you would be able to visualize it. So this one technically will convert that 2D lines and give it the depth to it. And the thickness of this one is based on that area. What it means if I go to let's say here and change that one, let me copy it first, to let's say 50. Let's see what happens. You can see the thickness would increase. So that's why this is the area we define and we try to visualize it as well. So that's what you need to do for the mesh. So the first step, once you set up your simulation environment, it's defining the mesh. That's the first stage among any computer-aided engineering softwares. So what I'm going to do, I'm going to stop the recording, do it slower for you, and then please follow it from what I'm going to do step by step to make sure that everyone done it properly. If I go to the folder, and if I go to this one, this is tutorial one, is the one that folder I created. If you go there, you can see now I have more files. That's the truss, that's the part, and that's the finite elements modeling and simulations that I have here. That's why I ask you to put in the folder. We haven't run the solution yet. If you save and run the solution, you can see the number of files will increase. So I would definitely recommend it to put in the folder because if you move any of these around, the solution won't be open later. Okay, so we've done the mesh, and now I want to go to the next stage, which basically the simulation stage. So I click on the truss sim. You can see the bar on the top become different. What I can do in here, I can apply the constraints and the loads. I can define where I fixed my part and what kind of loads I guess that I might have, and I'm looking to see how my product will respond to it. So first I need to start with the fixtures. The scenario that we are looking for, we are saying that we have two fixtures, and let's say we have these truss hanging from the wall. So there's a fixture here and there's a support from the wall, so it doesn't go back. So there's a support from the wall, and also there's a 50 newtons would apply on there as well. So we want to replicate that scenario. So what I need to do, first of all, I need to put it on that view so I can see what's going on. What I'm gonna do, I'm gonna apply the fixture on the back. So from there, if you want to see where those constraints in here. So once you're into the simulation level, make sure you're in the simulation viewer. In the constraint type, I'm gonna go with the user-defined constraint first. User-defined constraint, I would be able to specifically put the figure of degree of freedom of every single axis. First, I need to say where I want to fix. If you remember here, these are elements. Still, they are the 2D elements, the 2D lines. They don't have these thicknesses. These are just for visualization. So in order to do it, rather than I just pick the lines, I will go and activate the filter and I will change it to the node. And onto the node, I'm gonna pick the two nodes on the corner. Zoom, and then you should be able to see a node here. In my case, node 6, it can be different. Just one single point. And I will do it there as well. And I will pick that one into the corner. And you can see I have two nodes. So repeat it one more time. Make sure you activate the node in here. Pick those two nodes. And in here, I'm gonna apply the degree of freedom. What I'm gonna put the first 3 degree of freedom to the fixed. Do you know what are these degree of freedom? Do you have any idea what are those? What's the first 3 degree of freedom?
X, Y, and Z.
Well done. What kind of fixtures they have? So what I'm trying to fix? A translational or rotational? Any idea?
Translational.
Exactly, well done. Thank you so much, Charlie. So the first degree of freedom 1 is a translation X, movement in X direction. Degree of freedom 2, movement in Y direction. Degree of freedom 3, movement in Z direction. Degree of freedom 4, 5, and 6, these are the rotational. So I want to say that these are fixed, so I don't have any movement in X and Y, Z, but I can have the rotational. That's why it's free. And I click OK. And if I do that, you can see it's trying to visualize it for me and tells me these two area, they're fixed. Do you see that? These two area, they're fixed. And I only applied it to 2 nodes in here. And you can see here into the constraint, that's what I've done. So I can come here and edit it if in case you want to edit that. I have only 2 nodes that I applied. So that was the first fixture. The second fixture, if you remember, I was saying that we want to create a scenario that this one is supported by the wall. In order to do that, I'll again go to the constraint. So I have one more constraint I need to define, and it's called the simply supported. The wall is supporting it. So what I'm gonna do, I'm gonna apply the same side of it, but now is the bottom part, and I'll pick the nodes again. So make sure I go there to the filter, I activate the node, and I'll pick the node into the corner this time. Again, that node, make sure it's yes. And this one, I think your machine, you might see the nodes bigger because I'm using the wider screen. That's why it can be like that. Hopefully pick that node as well. Yes. And then it says simply supported, so I don't need to do anything. I'll just click OK. And if you see that, then I have then the simply supported on the bottom as well. So it's the top one and then the simply supported. Let me make sure. I think I have to apply the simply supported again because it didn't ask me for the vector. Okay. For the vector, so let me do it one more time because I don't want to confuse you. So for simply supported, I have to tell where is the wall. I haven't defined it yet. So I will do it one more time. So I'll go to the simply supported constraint, and the vector, I need to make sure that I will change it. It's the correct vector, by the way. So I will do it one more time, make sure I'm in the node, and I'll pick this one, first one, and I will go there, and I'll pick that one. So I have 2 nodes, and also I need to specify the vectors. Basically in here, you're gonna say, where do you have the support? What I want to put it, I wanna say I have the support from the, X direction. So you click on the specify vector in here and you put it X. If in case, I think your case would be like that. What you need to do, you click on there and you pick that direction, the X direction. Or if in case you don't have that option, you can come here and pick the XC. It's the same thing. It's exactly the same thing. As I said, you can go with this one. If you go there, it gives you the option to pick. So you will have the simply supported from the wall into the X direction. And then you click on OK. So what I have here, I have 2 fixtures. One on the top, which was user defined, that I fixed the degree of freedom into the X, Y, and Z. But I had another fixtures, is simply supported constraint on the bottom as well. So what we've done so far, we've done the constraint. So again, the first stage was mesh. We apply the constraint. We technically are making these scenarios for you. So what I said, we have the fixture, technically like hanging it from the wall, and then we have the support from the wall. That's why we use the simply supported. And in here we can see that actually we have done the constraint. So the next stage, I have to apply the load, mesh, constraint, and now is the load. And also make sure once you do the mesh, you need to define the material as well. So it's a mesh and material, constraint, and a load. The load scenario in here asks me to put the 50 newtons on the side that has the longer, and also it comes in that direction. So what I need to do, I need to come here, and once I'm into the simulation level, I'll go and click on the load type. I can see I have the different kind of loads that I will be able to pick. Depends on what kind of force I'm gonna to study. So one of the techniques of the FEA is really important. Of course, in here I will give you the examples, but in reality, you have to think what kind of first support I have, what kind of constraint I have. You need to define these, which of these I have, and then what kind of forces I have, and how much is the value of it. In this case, it's normal force. So for instance, if you want to study the pressure, you will go to the pressure. Any sort of design, of course, you have to study the gravity as well to make sure it's accurate. And these sort of things. So for instance, if there is acceleration, if there's a bearing move, these sort of things you have to define in here. In my case, I'm gonna have a pretty straightforward force. I click on the force, and again, because I'm gonna study the kind of in a nodal analysis, again, I'll go to the filter, make sure the node is picked, and I will pick these nodes, the one in that corner and the one in the other one, and the value of it was 50 newtons. Is along the vector force, but what direction is the negative y? So you can see I pick the y, goes up, it's a negative, so I just click here to reverse the direction. But of course you can come here and put it as a minus yc, but I think here is okay. I'll click OK. Now, even the force, it shows like that. Do you see it? It visualize it for me, that there is a force going down. So that's defining the load. So what we've done the mesh, material, constraints, loads. And now I'm ready to take it to the next stage, which is the solution, and then do the post-processing. Okay, so the next stage is taking it to the next stage, which basically applying the solution to that and then running the simulation. So first we'll go back in here to make sure in the constraint you have two constraints, you user defined and simply supported, and make sure they are active. If in case you modify them, they might become inactive. If that's the case, you right click and make it as a add to active solution. In my case, it's fine. Same thing for the load. Make sure you apply the force and it's active, and you see it like that. So everything is ready, and I want to ask the ANSYS, sorry, not the ANSYS, the NX, to run the simulation on it based on the solution which I already defined, which was the NX NASRA. So what I need to do, while into the simulation level, you can see next to the solution I have the solve. The solution is the NX NASRA that I have here, and I want to only apply to the solve. You can see into the solution, because I already activated these. If I click on the constraint, you can see it comes here. So it's already applied. If they are inactive, they don't come under the solution part. So everything is ready for me, and I just want to click on solve, and everything is fine. I don't change anything, and I will click on OK. So now you can see the DOS appear. The DOS technically take it to the next stage, and NASRA is a DOS space. So goes and apply this equation to every single element. In my case, I had only 23. But of course, if it's sampling complicated, it may more. A friend of mine, she's doing her PhD on the mesh analysis on the Airbus wing, and she needs to use the clusters and each of processes on a normal machine, normal powerful machine. Actually, it will take a week or something like that. So of course, it's not a simple thing to do once you have a complex part. So once you've done that, wait and make sure you reach to the level where it says it's completed. Once it's completed, click on cancel, and also you click the close this one. These are the informations that will tell you whether you had any kind of error or not. We don't need it. Once I've done that, then if I go from here, from the simulation navigator to the post-processing navigator, then what you would be able to see, let me bring it back here. It's okay. I will just look at it like this, but it's okay. So then I would be able to see the solutions that I have in here. So let me make sure that first of all the solution that we have is for this one. Okay. So make sure I double click on the structure. Once you double click on that structure, it opens up the result, and this is called the post-processing. If you notice, before I double click on that, it was inactive. Once I double click it, it will open all the structural analysis been done on it, and I would be able to visualize it. So let's go with the displacement. I want to see what's going on in terms of the displacement, and I'm gonna see the displacement in X direction. Do you see that? This is the displacement in X direction. You have the longer displacement onto the corners. And that's the value of it. Let's see the Y. Changes in the Y. A Z, or the magnitude of them. Also, I would be able to visualize it. Once I'm in X, if I go to animation, I can go and play there. So it animated for me. And this is really useful, especially once you're doing the presentation, to make sure that the people who will watch your presentation would be able to visualize it. And of course, you can stop it. Let's go to the rotational. You don't have any rotation in X, Y, and Z. But let's see the stress. You can see the stress, X, XY, YY, ZZ, or usually we go to the one misses. One miss is the one of the best one of doing that. And if I put it into the visualization, you can see what's going on in terms of the forces you will get and what's the maximum kind of stress you will get on that. So then whenever you see the kind of red areas, these are the areas I have to go back and redesign it. You will see then what's the maximum stress I will get on that. So we'll say these are the maximum areas. So I have to make sure that area will pass my expectation on that. So you will check the maximum force on there by the megapascal. And then these stress, you can do it two different methods. One is the elemental, one is the nodal. The amount of stress on each element, the elements, those are those lines that you created. The nodes in this case is the same thing. Every element was one node. Do you remember that? But if I said every element is 10 nodes, then the analysis in here, element nodal is different because it gets the average of every single node. In this case, it's the same thing. But next session, you will see that these results you get is different because every element consists of 10 or 100 nodes, for instance. Go check the one misses in here as well, and I will play it. So that's for the stress. The same things here for the reaction force. So you can see what kind of reaction I get from the part. I go with the magnitude, and I would be able to visualize it. And a reaction moment, a momentum of it for the nodal, and it's the same things. So you would be able to see that onto the, you can see the result and visualization of it, which we call it the post-processing. We don't want to take any graph for this one, but for the next session, we will take it to the more deeper level with doing the 2D and 3D mesh. And also we'll get the graph, how we'll be able to save it and how we'll be able to get the full report out of it.